natural and a flat top, pulse amplitude modulation, concept of the TTM. In that we will see the channel bandwidth of the palm, equalization, signal recovery through the holding. And then next one is the pulse width modulation, and the last one is the pulse position modulation, that is a ppm, the generation and detection of the all. Okay, so these are some outline. So we will start with the first outline, that is a need of the analog to digital conversion. Okay, can anyone tell me why we convert the analog to digital?
Ma'am, suppose the value is between 1 to 1024. Then,
Hmm.
if you want high or low value, so
Hmm.
for that purpose we need convert.
Okay, very
Or
good.
if there is
But
a condition, like
but
after so much value you get
hmm.
on, after
Oh,
such value you get off. So that
okay.
isn't.
Okay, but who understands such a language? Do you understand? If I am giving you 10101010 like the 16 number, okay. So can you easily tell me what is the meaning of that 10000110? Is it understandable to a single human?
Not, not so.
Not so. So who understand very clearly and easily?
Electronic circuit.
Yeah, electronic circuit. So which is the heart of electronic circuit?
Processor.
Yeah, it's a processor, or you can say the controller. Okay, so processor is a heart, and we can say the computer, which is which has also motherboard, which has also a processor. So when we are talking about the processor only understand the language the 1 0. Okay, as you told, that's it's a high and low. It's a very good, but a human being can't understand it. Okay, so that's why and we don't want to work on that. We are just a human, we are just want a easy system. Okay, so we are making a such kind of the system which is understandable by the microprocessor. But when we are taking the raw signal from nature, the always raw signal in the form of the analog. Okay, so what is our need right now? A maximum devices are made up of the digital. Okay, when we are talking about our home appliances, that also are digital. When we are talking about our jogging exercises appliances, that also are digital. आपका वॉच ले लो डिजिटल है, आप कोई भी चीज देखो, मैक्सिमम टेम्परेचर मेजरमेंट ले लो, मेडिकल सिस्टम्स आल्सो दे use the digital systems. Okay, so if we have a lot of digital products, so digital products requires the digital signal. But what is our actual raw data? A data raw signal is in the form of the analog. So what we will do, we will convert the analog to digital by using the converter, or we can say it's a translator. Okay, so as we will see here, the real world signal like the temperature, pressure, voltage, current, distance, or the light intensity, that is in the form of the analog, and we have to convert it into the digital representation of that signal. Okay, so now here you can see, just a bit, where is pointer? Okay, you can see here, this is the representation of the analog signal. It's a simple sinusoidal waveform. Okay, now if you want a digital signal from this raw signal, how you can how you will get it? By using the ADC, that is what, analog to digital converter. Okay, so by using this is nothing but what, this is the one kind of the circuit. That circuit is in the form of the device also. Okay, you can use it is a one IC also. So you can use that IC in your circuitry, or you can use the built up circuitry and your as a product with your device. Okay, you can use anyone. Okay, so we are thinking that we have a one circuit, that is the ADC circuit, and which is using here Okay, so what is the input of the ADC? As the name analog, the input required the analog signal. Okay, and it is a converter. That means it will convert analog signal into the another domain. So it will be converted into the another form, not domain. Sorry, it's a form. It's a digital signal. So it is a same signal which is represent in the analog signal like this, and it will be, you can see that is a digital representation of the analog signal. Okay, so as we know, there are some need of the analog communication we will see in detail. The digital signal is easy to perform mathematical manipulation of to the data, so that the computers and the microprocessor can store, analyze, understand, process, and display the result. Since the microprocessor deals with the digital information, once the data is in the digital format, it can be statistically analyzed, such as mathematically process. It is it to extract, isolate, manipulate information as the desire. One more need is that it can be compressed for the faster transmission and minimize the hardware storage capacity. Okay, then it can be encrypted for the security. Okay, that means for security purpose also we are using the digital signal. With analog, it is pretty easy to tap into the private phone conversation, digital encryption, security, privacy. These are some need of the analog to digital conversion. Now we will see some advantages of the analog to digital conversion, or we can say again it's a need, or you can say the advantages of the digital conversion, ADC conversion. That means advantages of the digital signal also you can say. It is easy to search and compare stored digital data. Means which digital signal? Now I am talking about only the digital signal. How, what are the advantages of the digital signal? It is easy to search and compare the stored digital data. Better noise immunity, supports high signal fidelity, channel coding can be possible, flexible hardware implementation, use of the regenerative repeaters is possible. Digital signal is more reliable as compared to the analog circuits. So these are some advantages. So by using all these things, okay, when we have to convert the analog into the digital form, the basic thing is what, uh, analog signal should be provided into the sampling, mm, uh, sampling block. Okay, so there are the three main block: input and sampler, means sample circuit. You have to provide your input to the sampler, then you have to quantize it, and the last one you have to encode it. Okay, so these are the three blocks. So when we are converting the analog to digital, the main process is the sampling. When we are providing the analog signal into the sampler circuit, that process will happen, that is called as the sampling process. Okay, it is a process of converting the continuous analog signal to the discrete analog signal. Okay, and the output of that sampler is called as the discrete signal. That's why we are talking here that we have to convert the continuous analog signal to a discrete analog signal. Okay, hence the sampled signal is a discrete time representation of the original analog signal. Now you have to distribute, you have to compare, you have to uh, distinguish all this signal by the graphical representation. You should know how to draw the analog signal, you should know how to draw the discrete signal, and how to draw the digital signal. At the time of the oral, external will ask, can you tell me what is the basic difference between the discrete signal and digital signal? They are not asking about the analog and digital, they will ask you about the discrete and the digital signal, and how you will get the discrete signal, how you will get the digital signal that we have to study basically. Okay, so as we have an analog signal as an input, how we will get a sampling signal? But when we are providing that analog signal to a sampler circuit, what will happen? That signal will, it is in the time domain. Okay, we are talking that it is in the time domain, or it should be in the frequency domain also. Okay, not compulsory that it is also always in the time domain. It should be satisfy the sampling theorem first. Okay, it should be satisfy the sampling theorem first. And what is the basically a sampling theorem? Fs is greater than or equal to twice fm. Okay, so what is the fs is the sampling frequency, and twice fm means what? It's a maximum frequency. When we are talking about the sampling theorem, okay, first we will cover the theory, then I will tell you with the representation. Okay, basically what the theorem state, that I will tell you. The sampling theorem state that the continuous form of the time variant signal can be represented in the discrete form of the signal with the help of the samples, and the sampled signal can be converted to the original form when the sampling signal frequency fs having the greater frequency value than or equal to the input signal frequency fm. So what is the mathematical representation here? Fs is greater than or equal to twice fm. Now you can see with this red color, fs is greater than or equal to twice fm. Means what? If if you can satisfy this signal, okay, as I told you in the practical, okay, first practical that we covered in the virtual lab, that what we have to do, we have to satisfy the sampling theorem. If we change the value of the uh, fs and fm, if they are not in the same rating, what will happen? You will not get a output as we required. Okay, so you will get some distortion in the output, and it will affect on the quantization, and it will affect on the digital signal also. So when the someone will ask you what is the sampling theorem statement, you should write down the statement in the statement form. Okay, and a mathematical representation of the sampling theorem, that you should know blindly, that you should talk blindly. What is the formula? Fs is greater than or equal to twice fm. But what is the fs here? Fs is the sampling frequency. Sampling frequency. Fm is what? Fm is the input signal frequency. मतलब क्या? Maximum frequency. Then such a condition is called as a Nyquist criteria for the sampling. When this is not a Nyquist criteria. When it creates a Nyquist criteria, but when the sampling frequency equal to the twice of fm, that means what? When fs is equal to, not greater than, okay, fs is equal to the twice of m, it is called as a Nyquist rate. This is again a part of our syllabus. What is the Nyquist rate? Fs is equal to twice fm. And what is the ff? It's a sampling frequency. What is the fm? It's a input signal. That is the this is your maximum frequency of the input signal. Okay, and what is the when such a kind of the criteria will not satisfy, what will happen? If the fs is less than twice fm, what will happen? It creates a aliasing effect. Okay, it creates a aliasing effect. So there are the three conditions that are possible for the sampling frequency criteria. They are the sampling, Nyquist, and the aliasing states. Okay, this is the sampling, this is the Nyquist, and this is the aliasing state. So you should know thoroughly that what is the sampling. Okay, sampling का मतलब क्या है? कोई तो भी एक frequency है that should be greater than or equal to twice fm. Okay, but what is that signal? Okay, देखो, this is our frequency. Okay, I will tell you with some representation. I have one more point. It's very easy to understand. देखो, just see, if this is the analog signal. Okay, I don't have cursor. Okay. Suppose this is the analog signal, a simple analog signal. I will not use anything
Ma'am,
on that signal. Yes.
ma'am, your
Yes.
voice got lowered.
Okay. Now is it audible?
Yes, ma'am. Yes.
Okay. 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 So as we have to convert, okay, we will go with the step. So you should understand. So this is the representation. Okay, this is the representation how we will convert the analog to digital by using the sampling theorem. Okay, but how actually will happen? Okay, how it actually will happen that we will see. Suppose this is the continuous signal. Okay, this is a simple diagram to show how the process will happen. Okay, a continuous time signal x of t will apply to the sampling switch. Okay, and we will apply the one pulse generator, that is a train of the values of the fs. Okay, so we require the two signals. One is the input signal, that is the analog signal जो आपका continuous form में रहेगा, and second one is the pulse generator. Pulse generator means what? It creates a one it is a one type of the signal with having the higher frequency. Having the higher frequency. Higher frequency means the lower time. Okay, so this fs, this is nothing but what the fs, and this fs and fm, the signal frequency of the this signal is nothing but what the fm. Now you understand from where we got the fs and from where we got the fm. आपका जो ओरिजिनल एनालॉग सिग्नल है, आपका जो ओरिजिनल एनालॉग सिग्नल है, this one, the frequency of the signal is the fm, and the frequency of this another provided signal is the fs. When we provide the fs, what we have to this is the actual one, so we can't modify it, but we can modify it. So what we have to take care about that, fs is greater than or equal to twice fm. Okay, so how much value we have to select of the fs? Okay, that fs is greater than or equal to twice fm. So first of all, what we have to do, we have to find out what is the fm, what is the twice fm, and we have to take the more than that value of as an fs. Okay, as we have to select the fs, जो train आपको select करना है वो, then we have to apply that fs to the sampling switch. Okay, so what we will get here, I will get a sampled output, and this is the mathematical representation, but you should know graphically also that how you will get it. Okay, so suppose this is nothing but what, this is our dotted, just concentrate on the dotted line, this is your analog signal, and this is your pulse. Okay, so as you know, this is the pulse and this is the analog, and these are the output. So how you will get such kind of the signal? These poles are taking a amplitude, or they are taking a amplitude with respect to this, but they are replacing the frequency of the fm by the fs. Okay, that's why what will happen, they are just what we can say, just taking a particular time period. Okay, just they are taking a particular time period here, 1 0 1, here we are showing the time period. Okay, we have to convert it into the fs, that 1 by ts. Okay, so with this, now combination of these two, you will get this. Okay, so this is nothing but what, the sampled output of the continuous signal. This is the representation of the signal. मतलब क्या हो रहा है, आपका जो एनालॉग सिग्नल है उसको पर्टिकुलर टाइम पे यहाँ पे कट आउट हो रहा है, और वो कब कब होगा, ये डिस्टेंस कहाँ से मैटर करता है, द डिस्टेंस इज मैटर, और डिस्टेंस इज डिफाइंड बाय द fs which you provide to your sampling switch. If you are taking the you are changing the value of the fs, the distance between these two will be change. Okay, so we have to take care that the distance between these two should be a less, distance between two should be a less. That means we will cover all the analog signal. Okay, and this standing line is nothing but it's called as a discrete signal. Everyone just concentrate, the standing line you can see here with the black arrow, this is nothing but what, the discrete signal. Okay, and always we are showing with the x of n ts. Okay, as you used in the ss also, you worked on that signal, discrete signal you have to process on. For the processing also we are using the discrete signal. Okay, so this is nothing but what the sampling basically. The sampling theorem for the low pass signal means what? The low pass signal having the low range frequency, and whenever this type of the low frequency signal need to convert to discrete, then sampling frequency should be at least twice or greater than twice of this low frequency signal. Why? To avoid the distortion in the output discrete signal. Means what we have to say here, as the question is related, will be related with the low pass signal, that the sampling theorem for the low pass signal. Actually we use the sampling theorem on the analog signal, and the analog is the modulating signal, and it should be always a low signal. Okay, so that's a simple one, that it is a low pass signal, and why we are using the sampling theorem to avoid the distortion in the output discrete signal. Okay, so following out some condition, the sampled signal does not overlap, and this sampled signal can be reconstructed to its original form. Means what? As we are providing the ADC circuit and the some modulation technique, so what will happen? Analog signal will be converted into the digital form, or we just got a discrete signal for our particular process. That signal will we just process that signal and we use for our circuit. Okay, जो भी आपको use करना है वहाँ पे हो जाएगा. But when we have to recover it at the as we are using in the demodulation, what you have to do? You have to use the DAC. As we used here the ADC, in the second part we have to use the DAC. DAC means what? Digital to analog converter, because again we have to get back a analog signal in the receiver. Okay, so when we are taking the get back in the receiver, it's necessary that you should apply the sampling theorem. Okay, to sample the signal does not overlap. If you are using the sampling theorem, it will not overlap, and it is very easy to recover your signal. Reconstruct means what? Recover it again in the original form at the receiver side. Okay, one more definition for the this sampling theorem for low pass signal. A continuous time signal x of t can be completely represented in its sampled form. Okay, and recovered back from the sampled form if the sampling frequency fs is greater than twice w. Okay, now see, some books refer the twice fm and some book refer the 2w. So both are the same, so don't confuse with this 2 fm or twice w. Actually when we are talking about the time domain, maximum books refers to it's a w. So where w is the maximum frequency of the continuous time signal x of t. Okay, so this is nothing but what the theorem. Shannon defined this theorem 1949. So this is the sampling theorem proof. This proof is categorized into the four form. Okay, so this proof is categorized into the four form. First one is what? Continuous time analog signal x of t. Okay, so what we are doing here, we are just a minute. Okay, we are taking some assumption here that x of t be a continuous time signal. Okay, x of t be a strictly band limited signal. X of t has a finite energy signal. X of t be a infinite duration signal. Okay, so as we have this condition and we are taking a x of t, so simple. Here we are representing the x of t with this represent graphical representation. Okay, second is what? Sampling function s of t is a unit impulse. As I told you in this first diagram, see here, this is the analog signal x of t, and this is the pulse generator, pulse signal. Okay, so this is nothing but what? Analog signal. कैसे लिया? The analog signal having some characteristic. We choose that signal. It should be continuous. It should be a band limited. It should be a finite energy, and it should be a finite duration also. But when we are selecting a S of t, you can write down the S of t. You can write down the H of t also. You can write down the any notation for that S of t and all. That is a unit impulse. Why I'm talking about the unit impulse? As I consider that you should know, but I'm repeating it again. Unit impulse means what? The amplitude of that signal, it should be always a 1. Okay, it is a delta of t. Unit impulse means delta of t. It's a for 0 times 0. The value means amplitude of that signal should be a 1. Understood? When we are talking about the delta of the unit impulse represented with the delta, and what is the representation of the delta of t signal? When the t value is 0, that means you should always define with this t. And when we are talking about the t, that for the t, the value of this signal should be a 1. Means what? The all the amplitude of this pulse should be a same, and it should be a 1 only. That's why it's called as the, we are selecting the unit impulse only. Okay, but what is the one more point we have to consider here? Now we are not taking a delta of t only, because we want a train, we want a number of pulses. That's why we are writing the signal in this form, the delta of t, डेल्टा ऑफ टी माइनस एन टी एस. जो भी आप नंबर डिफाइन करोगे, मतलब ये कब तक बढ़ेगा? जितना आप एन डिफाइन करोगे उतनी वो सारी वैल्यूज आपको आती जाएगी, मतलब तब तक वो ट्रेन है. नहीं तो अदरवाइज व्हेन वी आर टॉकिंग अबाउट द डेल्टा ऑफ टी, ये सिर्फ यहाँ पे दिखेगा. समझ में आ रहा है? ये कहीं से आ नहीं रहा है, कोई ना कोई सर्किट इसको जनरेट कर रहा है. दैट्स व्हाई यू शुड नो द सिंपल रिप्रेजेंटेशन ऑफ द सिग्नल दैट यू लर्न इनटू द एसएस. रिकॉल कर लो लगे तो वापस से, ठीक है? So uh, now we have a two signal. One is the analog signal and second one is the impulse signal, unit impulse signal. Okay, but now we are talking just about the amplitude. But what's about the frequency? So that frequency is nothing but the t of s. That is totally depends on your input. ये कैसे लोगे आप? ये कैसे डिसाइड करोगे कि ये कितना होना चाहिए? It's totally depends on this. क्यों? Can anyone tell me? Can anyone tell me? ये जो डिस्टेंस है टी एस, ओके, टी एस मीन्स द डिफरेंस बिटवीन दिस टू. Why this ts distance is depends on the first analog signal?
वेव साइन और
Hmm?
कोसाइन, साइन और कोसाइन वेव में या फिर
Nahi. Means what? Actually I'm not getting your answer.
ma'am, this analog signal is in the form of only sinusoidal or cosinal also is allowed.
Sinusoidal होगा ये. But I think you don't get my question. That when you are selecting the unit impulse, okay, आप क्या कर रहे हो? As I told you that just select a one unit impulse train. ओके, बनाओ एक ट्रेन बनाओ. आप आपको अगर मैंने एक सिमुलेशन पे बनाने को बोला, मैटलैब पे एक सिग्नल ट्रेन बनाओ, वैसे रिप्रेजेंट करो, ठीक है? सो व्हाट योर रिक्वायरमेंट, व्हाट यू विल आस्क मी, ma'am, what is the distance between these two? What will be the distance? That question you should ask me. Okay. So what will be my answer? That the distance between these two discrete signal is totally depends on the analog signal. Why? केयरफुली सुनो बेटा, मैंने प्रैक्टिकल के टाइम पे भी बोला था ये सारी चीजें, बिकॉज इट्स वेरी इंपॉर्टेंट पॉइंट. ये सिंपल है बट ये बहुत देर तक जाएंगे, मतलब लास्ट ईयर तक प्रोजेक्ट करोगे तब तक सैम्पलिंग आपके साथ रहेगा. ओके, व्हाट इज द मीनिंग ऑफ दैट? मैंने आपकी आपके अभी आपको क्या बोला? व्हाट इज द थ्योरम? एफ एस इज ग्रेटर देन और इक्वल टू ट्वाइस एफ एम. फ्रॉम दिस सिग्नल व्हाट यू विल गेट? यहाँ से क्या मिलने वाला है आपको? क्या मिलने वाला है? एफ एस,
हाँ मैम.
राइट? यहाँ से क्या मिलेगा, एफ एस, एंड एफ एस इज ग्रेटर देन और इक्वल टू ट्वाइस एफ एम. ओके, तो एफ एम कहाँ पे मिल रहे हैं, यहाँ पे. द फ्रीक्वेंसी ऑफ दिस सिग्नल इज नथिंग बट द एफ एम. एंड व्हाट फॉर व्हेन वी आर सेलेक्टिंग द, ये तो हमारे हाथ में नहीं है, ये तो गिवन है. ओके, ये एज इट इज लेना है, बट दिस इज इन अवर हैंड. सो व्हेन वी आर सेलेक्टिंग द phase, the how we can define that it should be a greater than or equal to twice fm. It should be a greater than or equal to twice. Understood? fs is greater than or equal to twice fm. So ये अगर दो है, ओके, सपोज कंसिडर fm शुड बी अ टू. टू हार्ड से एक रैंडमली वैल्यू लेती हूँ मैं. ओके, fm शुड बी अ टू. अगर ये दो है तो आपका fs कितना होना चाहिए? If my fm is 2, how much my fs?
4, greater than 4.
Yeah, very good. It's more than 4. Okay. If we are talking that if it should be a same Nyquist criteria, so it both are equal. Okay. But always it should be a greater than 1. To what purpose? To avoid the aliasing effect occurs in the output. अगर ये satisfy नहीं होता है तो at the end क्या होगा? The at the end मतलब क्या, इसके conversion के बाद क्या होगा? The aliasing effect will occur. Okay, or it will difficult to recover our signal. Okay, that's why we are satisfying the signal with the this theorem. Now I hopes that everyone understand. If anyone has any doubt, ask me again. क्योंकि इसी पे ही आपका कोई भी प्रैक्टिकल आए, कुछ भी हो, ओरल इसी पे ही होता है मैक्सिमम, क्योंकि ये बेस है हमारा सिग्नल एनालॉग का. ओके, सो ये हो गया आपका एनालॉग. The sampled signal x of delta of t. Now you got here the sample. Okay, जो as I shown you in the first slide, this is nothing but a representation of the sampled signal. ये आपका sampled मतलब क्या, discrete signal है. Okay, so sorry, x of delta of t is nothing but what, x of t into the s of t, multiplication of the two signal, that is nothing but what, the sampled signal. Now what will happen, जो जो भी हमने यहाँ पे लिया था, 0 ts 2 ts 3 ts, वो यहाँ पे आया 0 ts 2 ts 3 ts. Okay, as you can see here. Okay, दिख रहा है आपको? Okay, so you can see here the 2 ts. But what is the value of that particular ts and fs and all frequencies? It should be a, it should be a same as your an input analog signal. It should be a same with as your input analog signal. It is not one for all. As we define in the s of t, it's a 1, but now it's not a delta of t, it's a multiplication of the x of t and s of t. So what will happen, it will change the value with respect to the analog signal. This is nothing but what, the sampled signal. You can see it's a very good representation. Analog है ये आपकी इम्पल्स से इक्वल है. देखो ग्राफ पे अच्छे से दिखेगा. यूनिट इम्पल्स, यूनिट की बोलते हैं हम इसको, क्योंकि इसकी वैल्यू 1 होती है. दैट्स व्हाई वी आर टेलिंग इट्स अ 1 यूनिट इम्पल्स. ओके, इम्पल्स का मतलब क्या है, जिसकी वैल्यू 1 है, ऐसा एक सिग्नल. ओके, सो ये ट्रेन है. ट्रेन मतलब मल्टीपल वैल्यूज. So when we are multiplying these two signal, you will get such a kind of the representation, and it's called as the sampled signal. Okay. The last part of this proof is what, obtain the Fourier transform of the sampled signal. It's a representation. First, my Fourier transform of the x of t is the x of f, जो मेरा इनपुट सिग्नल था. फुरियर ट्रांसफॉर्म ऑफ द एस ऑफ टी, मतलब यूनिट इम्पल्स का फुरियर ट्रांसफॉर्म इज द एस ऑफ एफ. यू जस्ट कन्वर्ट इट टी इनटू द एफ, टाइम डोमेन इनटू द फ्रीक्वेंसी डोमेन. S of f is equal to the fs is greater than summation is minus infinity to infinity. Now you can write down with the mathematical representation, and again the same with the x of delta of t. Okay, you just go through it. I will upload all the ppt or this ppt on the Moodle right now. Actually it's completed. So these are some representation, and finally you got one signal, that is the x of delta of f is equal to fs greater than sorry, summation of the minus infinity to infinity x of f minus n fs. Okay, we just go through that because the main part is what now see here. Here, this is when we are talking about the f, you just write down this representation. This is the convolution. And when we are talking about the frequency domain, you can just write down the multiplication. No need to write show, or no need to give the any symbolic representation. Okay. Okay. See, I will tell you aliasing. So in next lecture we can start the pulse also. Okay. So what is the fs is less than twice fm? If you are we are just taking the fs is greater than or equal to twice fm, you will get what? See here, spectrum of the original signal x of t. If we have a one signal x of t, the spectrum will look like that. Okay. When the spectrum of the sampled signal, sampled means output signal. Okay. But when fs is equal to the twice fm, fm or fw means what? Nike straight. Okay. It is done with the Nike straight. So what will happen? It's very good. Okay. That means what? When both are equal, this spectrum ऑफ द ईच एंड एवरी सिग्नल, जो भी सिग्नल है एफ एस है, यहाँ पे जो जो चेंज होते जाएगा, मतलब डब्ल्यू माइनस डब्ल्यू माइनस थ्राइस डब्ल्यू एंड ऑल, तो ये अलग अलग फ्रीक्वेंसी के लिए जो स्पेक्ट्रम ड्रॉ होता है, दैट शुड बी अ स्टार्टिंग एंडिंग पॉइंट ऑफ दिस एंड स्टार्टिंग पॉइंट ऑफ द दिस, इट्स वेरी गुड. ओके, ये प्रॉपर होगा. इसका विड्थ भी सेम रहेगा. ओके, सो इट इज द लाइकेस्ट. बट व्हेन इट इज नॉट satisfactory, okay, when your signal is not satisfying that particular theorem, what will happen? It will just overlap it. See, you can see here the overlapping of these two triangles. Triangle is nothing but the representation of the spectrum. Okay, तो आपको ये दिख रहा है, it is just overlapping of the two spectrum. See here, this one also overlapping of this two spectrum, and that is called as the aliasing effect. Okay, so when the fs is greater than twice w, what will happen? When it is not an greater than or equal to twice w, so what will happen? It should some create a distance between these two triangles. Okay, so what will happen? Its fs is greater than or equal to the twice fs. So you may take a fs is greater than twice w, you may take this one also. Okay, not no problem will happen at the time of the recovery. But if you are taking is greater than twice fm, आपका आउटपुट ऐसे दिखेगा. If you are taking the fs is equal to the twice fm, आपका आउटपुट ऐसे दिखेगा. If you are taking the fs is less than twice fm, आपका आउटपुट ऐसे दिखेगा. And this is a prohibited, and it creates one error that is called as the aliasing. ये आपको पूछते हैं कि which type of the error occurs when we are not satisfying the sampling theorem, that's called the aliasing effect. Okay, and how we can minimize it? We are just satisfying the sampling theorem. We just increase the value of the fs, इसको बढ़ाओ. Okay, तो ये बराबर आएगा. Okay, there are the basically three types of the sampling. First one is the impulse, or we can say the ideal sampling. Second one is the natural sampling, and third one is the flat top